So if you're not a big fan of factorising just by inspection, here's a hack that you might like to work at. I'm going to call this one the AC method, mainly because if you think about quadratic formula, that one, the x squared coefficient of 5 is the A, 33 is the B, and the minus 14 is the C. So the AC method, what I'm going to do is start off by multiplying the A coefficient and the C coefficient. So what I'm going to do now, what I'm going to be writing here are not necessarily correct mathematical statements, so be careful. I tend not to include any equal signs in amongst this. So what I'm going to do is take that 5, multiply it by the 14, almost like kind of move it. So I'm getting rid of it from there. I'm going to leave that as plus 33, and there I'm going to write that A times C, that 70 is the 5 times the 14. So now what I'm going to do is factorise that one. So here come a couple of brackets, and let's go for x. And I'm looking for factors of 70 that multiply to make 33. So straight away I'm going to go 35 and 2. Because, yeah, 35 take away 2, there's a 33. So that needs to be a plus. That needs to be a minus. And slightly odd, I'm going to put a 5x there and a 5x in there. I know that 5x times 5x will leave it with 25x squared. Do not worry about that for now. As I said, this is a bit of a mathematical fudge rather than being 100% mathematically accurate. Because what I notice now is we've got a complex, so I can take a 5 out of that one. So let's do that. So we've got x plus 7, 5x minus 2. And then slightly oddly, I'm just going to say, okay, let's just ignore that 5 that I've taken out. And that thing there is our finished factorised expression. Let's just double check it. So we've got 5x squared, that's the bits in the middle. So we've got, there's my 35x, take away the 2x, and then finally there's the minus 14, and that's now all working out ever so nicely. So let's have a look at using the AC method on part B. So we've got 6x squared minus x minus 12. When we said kind of the A coefficient is there, the B coefficient is going to be minus 1. There's our C coefficient. So the first thing I'm going to do is do the multiplying of the A and the C. So we end up with x squared. I'm just ignoring a 6 for there. It's almost like I'm moving the 6 over to join C. So we've got x squared minus x. That becomes minus 72. Now we've got to factorise that one. So 8 and 9. So we've got x, that'll be minus 9, x plus 8. Now the 6 that the A coefficient, let's just pop those back in there. And like I say, seems slightly odd, but that's what you need to do to get this method to work. Now we'll notice on this one, let's have a look there. Yeah, we can take out a factor, and the factor we're going to take out is, let's take out a 3. So that's 2x minus 3. And we can also take a factor out of that one. We can take a 2 out of there. So let's write that as that's 3x plus 4. And now again, slightly oddly, what we do is just ignore the bits we've pulled out. So let's just ignore that bit there, ignore that bit there. And we've got 2x minus 3, 3x plus 4. And so that's helped with our factorising when we've got an A coefficient that's not equal to 1. Final quick check just to see if it's all working. So there we go, 6x squared. There we've got minus 9x. There's plus 8x. So that gives us the minus x that we're after. And finally, minus 3 times plus 4 is the minus 12. So it's looking like it's all working ever so nicely.